They shouldn't even need a tutorial. So what are we going to do this evening? We're going to do a little bit of matrix arithmetic. Right? Which involves addition of matrices. We'll do some subtraction. Right? We'll do a little bit of multiplication. And lastly, we'll deal with the matter of inverses. And on the inverses, well, there's really the hardest stuff comes in, right? We're going to talk about determinants. That's it between D and T. We'll talk about minors, right? We'll talk about cofactor. Then we'll talk about joint matrix. Right? So let's start with addition. That's the easiest. I hardly think you want me to show you that. And we have two matrices. You have to add them. First condition you have to make sure that they are the same order. Right? So they have to be of the same order, same size, same dimension, right? And then you can add them. Well, what do you do in addition? You just add to add corresponding terms, right? So you have what? 6, this 3 and this 2, you have 5, 5 on that one, 6, this 2 on this one, 3, 4 and this 4 is 8, 6 and this 2 is another 8, this 3 and this 3 is 6, this one and that one is 2, 2 and this 6 is another 8, and that's it. Do you need any more of, examples with addition? That's a very easy stuff. Huh? Anybody wants another one to be done, or you think you're satisfied with this?
Sir, I'm okay with that example.
Yeah, they're all the same, right? You just have to make sure that the two matrices are the same size. Because if you are adding corresponding elements, each element from the first matrix has to have a corresponding one in the second. And if the second one is smaller or larger, you're going to either have, in the case of this, if the second one is smaller, you're going to have elements in the first one that doesn't have a corresponding one in the second one, right? That's sort of the situation. So they must be of the same size. Keep that in mind. Let's deal with subtraction, which is just as easy, you know. Subtract. Right? And what you do? Again, you check with the condition. They must be of the same size, and they are in this case. You simply subtract corresponding elements, right? So you 1 minus 1, okay, the answer here, 0. 0 minus minus 1 is 1. 1 minus 2 is minus 1. 2 minus this one is 1. 1 minus 3 is minus 2. 0 minus 0 is 0. 2 minus 1 is 1. 1 minus 1 is 0. 3 minus 2 is 1. And that's your matrix. Simple as that. In addition to knowing the operations, I want you to, in the lecture, and I think some notes I sent to you, there are some properties of addition and subtraction that you must know, you know? Like addition, okay, whether it's commutative or not. Same thing with subtraction, whether they're associative, you know, all of those properties. Must know the properties because the matrix is so simple that I can hardly give you a difficult question. So I have to trick you with some kind of property and, you know, I have to trick you up somehow. That's what they pay me for, you know. Not really. But I have to test you those properties, whether you know them, you understand them, can use them, you know. Good. So let's go to a little bit of multiplication. So you have maybe all right. A scalar outside there, and you have a matrix in here. Right? So you multiply the scalar by every number in here, every number in here. And you get what? 3 by 1 is 3, 3 by 2 is 6, 3 by 1, the end there is another 3, 3 by this 3 is 9, 3 by 3 is 6, another 3 there is 12. See if you follow this. You multiply the number in front by everything in the bracket.
Yes, sir.
Can't get
Yes, sir.
as a guy on YouTube, they say life can't get better than that. But we're getting into a little bit of complicated things now. Matrix multiplication. Here's where things get a little complicated. Let's say now, now a matrix. Mm-hmm. Here you have so here is a 2 by 3, and here is a 3 by 2. You have to check the condition first before we multiply. The number of columns must equal to the number of rows. So yes, you can multiply. And your answer will be a 2 by 2 matrix. Right? So you're looking for a 2 by 2 matrix. Remember that condition. You have to check the condition first. So let's do the multiplication. One second. Let me just take out this here because I'm going to use the bottom here. So we're multiplying rows by columns, right? So we multiply this first row here by this column, right? So we're going to have 1 by 1 plus 2 by 3 plus 3 by 5. That's that number. Then this row by this column. Shift it on already. Go in here. 1 by 2 plus 2 by 4 plus 3 by 6, right? And then take this row by this column now, and that's going here. 3 by 1 plus 2 by 3 plus 1 by 5, right? We'll simplify it later. And then we take a row by this next column here. So we get 3 by 2 plus 2 by 4 plus 1 by 6, right? And this is the matrix. So let's simplify that. So what's it? 1 plus 6. That's what? 7. 7 and 15 is 22. Let's go over here. 2 plus 8, which is 10. 10 plus 18, which is what? 28. Let's come here. 3 plus 6, 9. 9 plus 5, 14. Here. 3 by 2 is 6 plus this 8 here. 6 plus 8 is what? 14. 14 plus 6 is 20. And that's your answer. Yes, hold on.
Sir, I really missed that. Can you please go over that again for me?
Okay, yeah, no problem. So when you are multiplying matrices, the first thing you do is check that they are what you call conformable, right? I like to use the word compatible. The notes I gave you in the video, I use the word conformable, right? And what I mean is that you need to check, okay, you need to write down, slide it down. Write down the size of this matrix. 2 by 3, right? This is a 2 by 3. 2 rows by 3 columns. And this one is 3 rows by 2 columns. Right? So you have to check that the number of columns in the first must equal to the number of rows in the second. And once those two numbers are the same, then yes, you can go ahead and multiply the matrix. The answer you get will be the number of rows in the first matrix times the number of columns in the second matrix. So we're expecting we're going to get a 2 by 2 matrix in the end. Right, you get that so far?
Yes, sir.
Good. So now we're doing the actual multiplication, right? So when you do the multiplication, you multiply rows, this row by this column. It's rows by column. So this entire row here multiplied by all these numbers here. You put it here. Right? That's this here. So 1 by the 1, you get 1 by 1, plus 2 by 3, that's that, plus 3 by 5. Right? And you simplify it. You add all of them up. You multiply and add, right? You get 22. To get this number here, you multiply the same first row by the second column. So 1 by 2, that's what you see here. 2 by the 4, that's what you see here. 3 by the 6, that's what you see here. When we multiply and add up, you get 28. Right? Then we use the second row now by the first column. That when you do that, that will go here. So 3 by 1, that's what you see here. 2 by the 3, that's what you see here. And the 1 by the 5, that's what you see here. Good. And when you, I think when you work that out, I think they get what? 14? 14, right? That is 14. And then finally, you do this row by this last column, right? So 3 by the 2, this 3 by this 2, that's what you see here. This 2 by that 4, that's what you see here. This 1 by the 6, that's what you see here. And when we do the arithmetic, we end up with 20. Right? If you have difficulty with it and you want to know, you want some practice there, you go online and they have an umpteen different we call matrix calculator, right? That will do anything for you. You just type in the matrix and they will multiply it for you. So you watch them and say, oh, no, I understand. They show you the steps, you know. People show you the steps. You gotta worry yourself, right? So we want to go to the hard thing now, the inverse. Huh? let's take an inverse. Um, let's hook up this nice one. There you go. 1, 2, 3. Yeah, let's call this matrix, sorry, let's call it E. I forgot to write A equals, right? Before you can actually find the inverse, smartest thing to do is find what we call the determinant of E. Because the name is not meaningless. The name determinant tells you, the number tells you that yes, this matrix does have an inverse. If the determinant is 0, the matrix doesn't have an inverse. If the matrix, the determinant is a number other than 0, well, the matrix does have an inverse, right? And there are more than one ways you can find the determinant, right? There are several ways, in fact. But as I highlighted to you, this is not a course on matrix alone. We got a whole set of things we did, a whole set of financial maths. We're doing a little bit of matrix. We're going to do some linear programming after this. Then we have to do calculus. It's like they put 4 courses in one. So I can't teach you every possible thing about matrices. Matrices is a whole branch of mathematics, right? So I can only teach you maybe one method, right? And I did show you that to find the matrix here, the determinant of this matrix. This is what we can do. Okay. The sign convention is, okay, there's going to be a plus, there's going to be a minus, and then there's going to be a plus, right? And I'm going to use the force rule. So I'm going to take that 1, and I'm going to cross out. I'm going to cross out the row and the column that 1 is inside. And you see this matrix that is left? I'm going to put it here. I'm going to find the determinant of that. 1, 4, 6, 9, right? Minus, good. The next I'm going to take the 2 now. Oh, 5. I wonder if I could erase. Let me erase the. Yeah, good. So now I'm going to take this 2 here. I'm going to cross out the row and the column that it's inside. And I'll put a 2 here. And I'll put and this is like what I call the minor matrix, right? 0, 4, 5, 6, 5 now. 0, 4, 5 now. I'm going to find the determinant of that. Just now, right? I'm writing. Plus, we go back again now and take the third element, that's the 3. Right? So we're taking this 3 here. Cross out the row and the column that it's in, and these here. Okay, so you put your 3 here times the determinant of 0, 1, 5, 6. Good. We're going to do it here now. So it's positive 1 multiplied by what's the determinant? 1 by 0 is 0 minus 6 by 4, which is minus 24. Oh, sorry, minus 24. Right? Because 1 by 0 is 0. 0 minus 6 by 4, which is 24. So 0 minus 24 is minus 24. Over here now, minus 2 by 0 by 0 is 0 minus 5 by 4 is 20. So you get minus 20 plus 3 times 0 by 6 is 0 minus 5 by 1 is minus 5, right? So let's see what we'll get here. So here we'll get minus 24. What will this be? This will be positive 40. And this will be minus 15. What do we get here when we add those in? What are we getting? 1? 1 is the answer. Anybody following?
Sorry, I got 1.
Yeah, that's it, right? So our determinant is 1. I remember, I think inside either the notes or inside the what is it? The video I sent to you. There was another method, maybe I can write that method here. Let me see. Give me a sec. This was an alternative method. So you take, okay, you got a matrix 1, 2, 3. What was it? 0, 1, 4, 5, 6, 0. Take this first and second row and write it back in. 1, 0, 5, 2, 1, 6, right? And I'm trying to remember what you do. Take this 3, multiply them, take this 3, multiply them, multiply this 3, and add them up. So what will it be? 1 by 1 by 0, all of this is 0 plus 2 by 4 is how much? 8. 8 by 5 is what? 40 plus 3 by 0 by naught is 0. Okay. So this minus, and you take away these now. This by this by this, this by this by this, and that by that by that. Let's see. So minus 5 by 1 is 5. 5 by 3 is 15. 6 by 4 is 1. 24 by 1, 24. Well, these here will turn out to be not, right? That's not. And you indeed get 1 as the answer again. I don't know if you like that better. It's faster or whatever. That's your determinant. So what we found out here, because the determinant is 1, right? Since the determinant is 1, the matrix does have an inverse, right? And we can now find that inverse. Now, before we can do that, we need to find what we call the cofactor matrix, right? The cofactor matrix. How do you do that? So maybe make a note. Our matrix has determinant 1. So the inverse of the matrix is equals to 1 over the determinant times the adjoint of matrix E. So we already got the determinant, so we're happy. 1 over 1 is 1. We ain't got no problem there. We need the adjoint of E. Now, the adjoint of E is actually the transpose of the cofactor matrix, right? Of the cofactor of E, which I'll put a little subscript A there, right? I'm wondering, did I use the right yeah, I'm using a little a as a subscript, meaning the cofactor of E, right? Well, that is the question. How do you find the cofactor? Right? How do you find the cofactor matrix? So that's some amount of work, and I'll just show you what we do. So, all right, so we have to find the cofactor first, right? So let's get the matrix back. We'll do the transpose and so later on. So the matrix is 1, 2, 3, 0, 1, 4, 5, 6, 9, right? That's the matrix. So the cofactor matrix, I'll write it big here, a big fancy thing that happens. So there's a certain sign convention you use, right? In the notes, I gave you something -1 to some power and all, but let me shorten it. For the 3 by 3 matrix, you start with a plus, then a minus, then a plus. Then down here, you get a minus, you get plus here, and then you get a minus here. And then you have a plus, and you have a minus, and then you have a plus. Now, what goes here is the minor, right? The minor of R, right? You see this force term here? See this force term, the force element 1? It's like you draw a line through there and through here. And you see these elements that are left? 1, 4, 6, not, you put them there, right? You do the same with the second one. Where this 2 is, you draw a line through there, and you put these elements, 0, 0, 4, 5. 0, 0, 4, 5. And lastly, the space here looks small. You take this 3, draw a line through there, draw a line through there, and these elements that are there, 0, 1, 5, 6, you put there, right? And you do the same for each element, right? Each element. I'm going to write them down here. And when you watch back this video, and you could watch now, right now, and tell me if I'm right. Down here, the minor matrix is going to be 2, 3, 6, 0, right? Down here, you're going to have 1, 3, 5, not. Down here, you're going to have 1, 2, 5, 6. Down here, you're going to have 2, 3, 1, 4. Down here, you're going to have 1, 2, 0, 4. And down here, you're going to have 1, 2, 0, 1. And by now, are you getting where I'm getting these numbers from? Where are we getting these numbers from?
Yes,
Sir, it's
sir.
kind of confusing me.
All right. I did the first line. Let me go to the second line. So this second line, where do I get these from? Well, I give you the sign in front, and this is the normal sign convention. Plus, minus, plus, minus, plus, minus, plus, minus, plus. You don't question that. You memorize that. Where do I get 2, 3, 6, and not? Well, is this number 0 here? Take the row out and take the column out, right? And what will you left with? 2, 3, 6, not. That's what I have here.
Oh, yeah.
Right?
Got it.
Go to this one now. Go to this one. So where do I get this from? You take this one, cross out the row, cross out the column. You get 1, 3, 5, 6. Oh, 0, 5, 0. That's what it is. Take the 4, cross out the row and the column. You get 1, 2, 5, 6. That's it. And you do the same thing for these here, and you'll get this. You watch back this video.
4, 5. Shouldn't it be 4, 5, 0?
Somebody asking something there?
Yes, sir. Where you have 0, 0, 4, 5. Shouldn't it be 0, 4, 5, 0?
Down here.
Yeah, in the middle.
0, 0. Oh, yeah, yeah. Oh my. Somebody paying attention, boy. I do the deliberately, you know.
Okay, sir.
Very good. That is very good. Somebody tripped me up there, boy. So you're saying this has to be that. Great. I'm glad that you all are following. Very good. I wonder where else I made a mistake. Yes, Yolanda.
Sir, so do we have to what must I say? Do we have to go it by row, or it's supposed to be in an order, or we can just do it and come up with that answer?
Well, it depends on what I ask you. As I said, there are online calculators that will do this at an instant and
Okay.
put the answer. But you never know. I can very well ask you, well, all right.
I know, sir, because being honest with you, that test, it was so tricky.
Yeah.
Yeah, true, sir.
Well,
Sir, we're begging for an assignment at least to make up with that scores.
you got 3 tests to make up. How are yourself?
Sure, sure, test, sir. Give me something else of the beast.
Nah.
Worth it.
It's one of the things I don't do. I have a policy of no makeup.
No makeup?
Because if I have to give you a makeup, I got to mark a whole set of words. 220 you in the class, you know. Don't forget.
But sir, why you assign so much marks for those tests? They're like 50 marks.
Yeah. You want plenty marks?
No, I mean
Sorry, I
like
got 24 out of 50. I felt so dumb.
well, I got 11. Oh, how worse can this get?
This thing is being recorded. That is why you have 3 more tests to make up and hope this one is going to be easier. So you never know, right? Okay. You might have an online calculator that will spit out. You type in your matrix and you will spit out the inverse. But I might very well say no. I want tests to see whether you all know these steps. And I can very well take this matrix and I put an A down here, A down here, a B down here, you know? And so, right? And I say, well, what is the value of A and B? And you got to know, well, what A must be and B must be. You understand? Because the AI probably wouldn't tell you that. You understand? It's kind of forcing you to know your stuff. I think this was a 0, right? It was a 0 there and a 0 there. Good. So now that we have the cofactor here now, the cofactor matrix, right? As a matter of fact, this is what you call the matrix of minors. Because what you're seeing here, these are the minor matrices, these little ones. Right? And the cofactor is when you actually evaluate this now. So when we evaluate this, tell me if you are seeing this and you can do it mentally. Minus 24, gotta go here. Minus 20 gotta come here. Minus 5 gotta come here. Tell me if I'm right or wrong or what. Minus 18 will come here. Minus 15 will come here. Minus 4 will come here. Am I right? Let me see. Minus 24, yeah. So the minus another. This is minus 20 times that is a plus. Right? When you change the sign. You are change the sign. So this is going to be minus. This is going to be plus. That is okay. This one is going to be a plus. That's okay. This is going to be a plus. Now 5 here. Minus 4. And then you don't
Sir, the 5 is supposed to be minus 5 and not plus 5.
here, down here. This one here.
The first row
This one.
at the
Okay.
bottom.
0.
No.
This one?
The your answer is at the bottom. You have minus 24 plus 18, and then you have plus 5. But isn't it supposed to be minus 5?
Let me see. 2 by 4 is 8. Minus 3 is positive 5. It's right. It's correct. So your cofactor matrix is equal to that, right? I can use a subscript here. Cofactor of A is that. Right? Now, the adjoint of A. I scroll up. Adjoint of A is equal to the transpose of this matrix, which is, so you're going to take the row and make it into a column. So you get minus 24. The 20 is going to come here. The minus 5 is going to come here, right? So that minus 5. The row becomes the column. The second row is become the second column. 18 minus 15, 4. Third row is going to become the third column. 5 minus 4, 0. So that's your answer. Right? You make the row into the column. Row into the column. So this row becomes this column. This row becomes this column. This row becomes this column. And your adjoint, the adjoint of, adjoint inverse now, we're ready for the inverse, is equals to 1 over the determinant, which is 1, times the adjoint, which is this, right? Minus 24, 18, 5, 20, plus 15, minus 4. Right? And of course, you multiply this by 1 remains the same, right? So the inverse is really that. This is. But multiplying it by 1 doesn't change anything. Did you follow so far? Let me give one trick for y'all to try. I think I gave them this morning. I gave them this matrix. A equal, and I think I gave them a matrix. Unless you watch the video. Find the determinant of this matrix. Because you have to find the determinant to know whether the matrix has an inverse or not. Find the determinant of that. You are working on it, right?
Yes, sir.
Yes, sir.
Y'all taking a long one?
Sir, I don't know if this is correct. I got 0.
Yeah, that's the correct answer. Funny as it looks, it's a singular matrix.
I got 0 too, sir.
Huh? Yeah. It's a singular matrix. Right? You know what? We got a couple of minutes more. One last little exercise. We got the inverse of A here, right? What is inverse matrix? And what was the original matrix? The original matrix was what was the original? This was the original. When you multiply these two, what will you get? Take this and multiply it by this. Put anyone in front. Anyone. I would advise you put a smaller one in front with a smaller number. Multiply these two matrices and see what you get. So in other words, you are multiplying a matrix by its inverse.
Sir, since they're made up of the same amount of rows and columns, we're multiplying negative 24 with 1.
Yeah. So you don't have to multiply this one by everything. It's already the inverse. Multiplying by one doesn't change nothing.
I'm talking about the column at the bottom. The two
Yeah.
that we're
Multiply this row by this column to the answer here, you know. Imagine I give you a test and I said, multiply this by this. What will the answer be? And I give you some choices. Oh, I didn't get it yet. Y'all taking long, man.
Star 111.
Let me hear it.
111.
What are you saying? 111?
Long words. Long way.
No, you're supposed to get 100.
No, I didn't get that. I
Zero,
got all three in one.
001. That's all.
Yeah, that. Can you show us how you got that?
But I'll leave you to think about it because a matrix by its inverse should give you what we call the unit matrix. So you have all weekend to think about how I get this miracle. Maybe I'll give you a start. Give you a start. What is it you have? So you got 1, 2, 3, 0. I hope I had the right matrix in 5, 6 now. Okay. Times, what is that? Minus 24, 18, 5, 20, minus 15, minus 4, 5, 4 and not. So let me go up here. Good. So let me go with this row by this column, right? So 1 by minus 24 plus 2 by 20 plus 3 by minus 5. How much is that work out? Minus 24, yeah, you're supposed to get 1 million. Right? Let me go with this row now on this column. So I have 1 by 18 plus 2 by minus 15 plus 3 by 4. So this is 18 minus 30. 18 minus 30 is 12, right? Negative 12. Negative 12 plus 12 is 0. You see that? So I got my 1, I got my 0. And I'll bet my last dollar that if you multiply this row by this column, you're also going to get naughty. Right?
I understand. Sorry. So what I did wrong, I put the bigger column in front and the smaller one behind.
No, you're supposed to get the same answer. Same answer. It doesn't matter.
No,
Generally, matrix multiplication is not commutative. However, when you're dealing with a matrix and its inverse, the order doesn't matter. So whichever one you put in front doesn't matter. You're supposed to get the same answer. All right, so that's the closing lesson here. You got to get this. You got to get this at the end. Unit matrix. A matrix by its inverse equal to the unit matrix. Always. Always, always. Good. So that's our time basically. I'll make this available to the other students